morning, good afternoon, good night, depending on when you're seeing this video. Today we're going to do measures of central tendency. This is 8-1, so make sure you label this in your notebook. Make sure to write anything that I write down as well. Remember that with this video, you need to take advantage of the fact that you can rewind me or listen to me again if needed. So let's go ahead and start the notes. Measures of central tendency. I am sure that you have worked with some measures of central tendency. First, we're going to define it. Measures of central tendency are values that help us describe data. Okay, so some of us have worked with these 4 types of measures of central tendency. We have worked with mode. Mode is the number in the data that appears the most. So that is what mode means. If we were given a large set of data, the number that we would see the most reoccurring would be the mode. The mean is the average of the data. In other words, we were to add up all the numbers and divide by how many there are. The median is the middle number in the data when it is arranged from smallest to largest. The range, which I think is something that sometimes confuses us, is going to be the difference between the lowest and the highest number in the data. So make sure that you're writing this down in your notebook. So these are measures of central tendency that we have worked before, hopefully. And we're going to use some of these, not all of these, to apply it to something new, and that is what we call the box and whiskers plot. Okay, so we're going to define the box and whisker plot as a graphical representation of the distribution of data. So we have seen bar graphs before, we have seen line plots, things like that. But a new type of plot that we're learning today is called the box and whisker plot, which is just a different way of organizing data and interpreting what it means. So if we look at the picture right here, down over here, this is a box and whisker plot. Notice that we have these 2 little lines here, which we consider our whiskers, because they're sticking out like that. So this is our whiskers. Again, if I were you, I'd probably write this down somewhere in my notebook. So that's going to be my whisker, and this is also another whisker right here. And then we have the box in the middle. And each of these points in the box represent different things. The very first point we see right here is the minimum value. It's going to be the lowest value in the data. So if I were you, I would draw this box and whisker plots, and I would label this point right here the minimum value. So what would be the lowest value in this data? 16. So the lowest value in this box and whisker plot is 16. Okay. And just like there is the lowest value right here, we also have, so this is my lowest one right here, we're going to have the maximum value. So this is what we're going to consider my maximum value. The maximum value is the highest value in the data. So in this box the highest value is 28. Again, I'm looking at the bottom numbers right here. We got 28. Now, this is what we call the first quartile. And please make sure you're writing this down. The first quartile is also abbreviated as Q1. And the first quartile, it's a little confusing to understand at first, but we're going to define it as where the first 25% of the data falls. So Q1 is going to be at this line right here, Q1. I do want to emphasize that the 1 is a subscript. In other words, the 1 is smaller than the Q. The Q is uppercase. And just like when you have an exponent that you write it small, the Q1 is also, the 1 is also small, but on the bottom. So that's called a subscript. So this is the Q1. So in other words, 25% of the data exists between the numbers 16 and 18. This is 25% of the data. And that's how we define the first quartile. The second quartile, we're going to define it as the median of the data. So, and the median falls halfway between the data. So the first 50% of the data falls before at that line or at that number. So right here, if we look at it, 22 would be our median. I'm just gonna put MED because I can't write well on this with this pen. So I'm gonna write median. And from 16 to 22, that would be where 50% of the data falls. And if you can guess it, for the third quartile is where the first 75% of the data falls. And you guessed it correctly. Where is the third quartile? The third quartile is at this line right here. This is your third quartile, which we label Q subscript 3. Again, the 3 is supposed to be smaller than the Q, but I cannot write that correctly. So let's move on to the interquartile range. The interquartile range, you can find it by taking the third quartile, taking Q3, and minusing Q1. So in this example, our Q3 is 26, and our Q1, oops, there we go with this pen that doesn't work. And our Q1 is 18, so we would do 26 minus 18, and that would give us our interquartile range of 8. So the interquartile range for this is 8. Based on this information that we have to interpret from the box and whisker plots, we will have different types of questions to answer. Luckily, we do not have to make a box and whisker plots by hand, like doing all the algebra by ourselves, and we have technology for that. So let's take out our calculators, and we're going to write down this example. So we're going to write down this example. This is example number 1. This is going to be the highest temperatures in North Carolina, and we're going to make a box and whisker plots for it. Before we can make a box and whisker plots, we need to understand some of the symbols that we're going to see. We're going to see this X bar in our calculator, and I'll show you how to do that in a minute. And that X bar is going to represent the mean. So write this down. N is going to represent the amount of numbers in the data. So how many numbers are in the data? For example, in this one we would have 1, 2, 3, 4, 5, 6, 7. So N in this case would be 7. The minimum mx represents the minimum value in the data. Q1 is going to be the first quartile. The MD is going to represent median. Q3 is going to represent the third quartile. And max M is going to represent the maximum. So we're going to take out our calculators. And remember to always clear your calculator if you need to. We're going to go to Stat. And we're going to be putting in this set of data. So we're going to go to Edit, Enter. And we only need one set. So do we need 7, 8, 9, 10, 11, 12? Or do we need 73, 77, 79? Well, here our data is about the temperature of North Carolina, so we're going to need this data here. So I'm going to go ahead and plug that data in, and you make sure you plug it in. So I was able to plug in my data. Now, this is where we need to find this information to make our box and whisker plots or understand some of the data. So we're going to go to Stat, and we want to calculate. And we want to calculate the stats about this data. One variable stats, because we only used one list of things. So we're going to press enter. And we use list 1, so we're going to press enter again, enter, enter. And this is very important information. As you can see here, this is the X bar. That's how you read it. The X bar, as we covered over here, is the mean. So the mean of this data is 82.71. So I'm going to write it on to the side, 82.71. This sigma and this other sigma is not important to us. This little alpha symbol will be important to us, but not right now. N equals 7. Like I told you, what was the amount of numbers in the data? There was 7, so it gave us that N was 7. And then it gives us the minimum. What was the minimum value of the data? 73. So the minimum value is 73. And here's the first quartile, which thankfully we do not have to calculate on our own. The first quartile is 77. So the first quartile is 77. The median is 82. Again, we did not have to do any of that by hand, thank God. And quartile 3 is 91. So the third quartile is 91, which also happens to be the max X. So the max X is also 91. And so now with this information, we can build our box and whisker plots. So I'm going to go ahead and draw box and whisker plots, and I hope you do the same as well. So this is not the best box and whisker plots, but it is very hard to draw using the technology I have, so I apologize. Okay, so let's go ahead and label our minimum value. Again, the minimum value was 73, and the minimum value goes under the first dot right here, so I'm going to label that dot 73. Again, excuse my bad writing. The first quartile goes at the first line right here, so I'm going to label this part 77. The median falls in the middle, so I'm going to draw that in the middle, or where 82 would fall on this box and whisker plots. 82 would fall probably somewhere around there. So I'm going to draw my median right there, 82. Again, this is not an accurate box and whisker plots, it's just I had limited technology. And the third quartile is 91. And the max is also 91. So actually, this box and whisker plots would not have this whisker because that is the third quartile and the maximum. So it would look something like that. So thank you guys. Hopefully that works and helps you understand how to draw box and whisker plots. Try drawing a box and whisker plots for this set of data. This would be 2 box and whisker plots, one for Pullman and one for Seattle. So take a minute and write this down in your notebook and make a box and whisker plots using the same information I did in the previous example. Make sure to continue checking your Canvas or wherever it is that I post these videos so that you can follow up with the next videos. Have a great day. Bye-bye.